Yeah, again, motivation for double length hash functions is that many n-bit block ciphers exist of size approximately and equal to 64, and the single length hash codes of this size are not collision resistant. For such ciphers, the goal is to obtain hash codes of bit lengths uh, twice n, which are collision resistant hash functions. In the simplest case, the size of the key used in such hash functions is approximately the same as the block length of the cipher. In other cases, hash functions use larger keys. It's double length, as we talked before. Another characteristic to be noted in such hash functions is the number of block ciphers operations required to produce a hash output of block lengths equal to the of their cipher, motivating the following definition here. Following definition. Sorry. Here, let hash function h be an iterated hash function constructed from a block cipher with compression function f, which performs S-block encryptions to process each successive n-bit message block. Then the rate of this will be 1 divided to S. The hash functions discussed in this lecture are summarized in this table. Here you can see the Meyer, and Davis-Meyer, Prenell, MDC2, and MDC4 with this. Yeah, and these Meyer and MDC2 algorithms are the basis, respectively, of the two generic hash functions in ISO standard 10118, each allowing use of any n-bit block ciphers E, and providing hash codes of bit lengths M lower than and equal to n, and M lower than and equal to 2n, respectively. Here, it's the rates of these hash functions, and also here you can see the three single length rate on MDC based on block ciphers. It's the scheme of them. The first three schemes described, I will describe here, and it's illustrated in this slide, and it's closely related single length hash functions based on block ciphers. This make use of the following predefined components. First one, it's the generic n-bit cipher E, parameterized by key, symmetric key, a function G, which maps n-bit inputs to keys K, suitable for E if keys for E are also of length n and G, might be the identity function, and the third parameter is the fixed initial value suitable for use with E. Here we can see the here we let's talk about the algorithm of the first our Meyer hash function. Here the X is the bit string. In the output we will have a n-bit hash code of X. Yeah. In the input X is divided into n-bit blocks, and padded if necessary to complete last block. Denote the padded message consisting of the n-bit blocks x1, x2, etc. A consistent n-bit initial value must be pre-specified. The output will be this kind of, and the h0 will be the equal to 4, and we will have the hash function. I will show you this later.